Hello my friends and welcome back to the You Can Do TV channel. At the heart of Zurich's historic city center, the VBZ Central and Limit construction project represents one of the most complex urban infrastructure upgrades ever undertaken in Switzerland. This site is not only a major public transport node but also a densely built heritage zone, requiring extreme precision in planning and execution. The project focused on the renewal of tram tracks, underground utilities, drainage systems, and pavement structures, while maintaining continuous pedestrian and public transport access. Work sequences were carefully phased to minimize disruption, with temporary track diversions, night shifts, and tightly controlled logistics corridors. Excavation operations were carried out in narrow working widths, often directly above existing service tunnels and foundations. High-precision surveying and real-time monitoring ensured settlement control and protection of adjacent historical buildings. Specialized compact machinery was deployed to operate within limited clearances without compromising productivity. A critical component of the project was the installation of new reinforced concrete track slabs, vibration damping layers, and noise reduction systems, improving long-term ride comfort and infrastructure durability. Utility relocation included water, sewage, power, and communication networks, all coordinated within a highly congested underground environment. Material handling relied on just-in-time deliveries and short-term staging areas, as on-site storage was extremely restricted. Traffic management plans and safety systems were implemented to separate construction activities from public circulation at all times. The VBZ Central and Limit works demonstrate how advanced engineering, meticulous coordination, and urban construction expertise can successfully modernize critical transport infrastructure within one of Europe's most sensitive city environments. At the Van de Vlist facility in Schluenen, a Caterpillar 992K wheel loader is prepared for long-distance heavy transport under the supervision of drivers Jeffrey and Roloff. The machine, previously imported from Germany, is now being relocated for onward shipment to a Belgian seaport, where it will continue its international logistics chain. The loader is positioned on a low-deck, narrow-bed trailer equipped with pendulum axles, hauled by a 5-axle Volvo FH16 rated at 750 horsepower. For dimensional compliance and stability, the bucket and operator cab have been removed, while the steering structure remains installed, forming the highest point of the load. During the inland route toward the motorway, the trailer's axle system is hydraulically adjusted to prevent the loader wheels from contacting the road surface. This operation highlights the precision, coordination, and technical control required when transporting ultra-heavy mining equipment safely and efficiently. Perkins STC was contracted to relocate 7 industrial engines, each weighing 637,000 pounds, over a 61-mile corridor from a port in Michigan's Upper Peninsula during the summer of 2018. Because of the extreme mass and dimensional envelope, this project required more than 18 months of engineering, permitting, and route validation before any movement could begin. The transport operation utilized a 400-ton, dual-lane, 48-axle suspension beam trailer, distributing approximately 24,000 pounds per axle to control pavement and bridge loading. Overall convoy dimensions reached 391 feet in length, 22 feet in width, and 19 feet in height, making night travel mandatory and requiring continuous escort and traffic management. Multiple route surveys, test fits, trial runs, and crew training sessions were conducted, supported by third-party specialists and government agencies. A coordinated road train configuration and detailed engineered drawings ensured safe passage through critical points, including a roundabout and restricted roadway sections. The complete relocation program was executed over 3.5 weeks, demonstrating the level of precision and planning required for ultra-heavy transport logistics. The transportation of the main equipment, the gas turbine, for the Hanum power plant represents one of the most complex and technically demanding stages of the project. After completing the marine transport along the Aare Canal and the Han River, the oversized and high-value unit enters its final overland transport phase to the power plant construction site. The gas turbine features extreme dimensions and mass, requiring strict control of structural loads, vibration levels, and dynamic stability during movement. For this reason, the transport configuration employs multi-axle hydraulic modular trailers with independent suspension and electronically synchronized steering. This system distributes the load evenly over the pavement, minimizes axle pressure, and allows precise maneuvering through constrained urban and industrial corridors. The convoy operates at low, controlled speeds and is supported by escort vehicles, route supervisors, and traffic management teams. Prior to mobilization, detailed route surveys are conducted to verify turning radii, bridge load capacities, pavement conditions, gradient limitations, and overhead clearances. Temporary road reinforcements and traffic diversions are implemented where necessary to ensure safe passage of the heavy transport. At the destination, heavy lifting equipment and auxiliary handling systems are pre-positioned to receive the turbine immediately upon arrival. This includes positioning of cranes, jacking systems, and support frames to enable controlled offloading and final alignment. The integration of transport and lifting operations significantly reduces handling risk and improves installation efficiency. This operation illustrates the high level of coordination required between logistics engineers, structural specialists, lifting experts, and local authorities. Every phase is governed by strict safety procedures, real-time monitoring, and continuous communication between convoy members. The successful delivery of the Hanum gas turbine demonstrates the effectiveness of advanced heavy-haul technology and disciplined project execution. It confirms that, in large-scale power generation projects, precise planning and engineered transport solutions are essential to maintaining schedule integrity, protecting critical equipment, and ensuring safe, reliable project delivery. This operation documents the transport of an oversized and overweight industrial load from Přerov in the Czech Republic to Bratislava in Slovakia, covering a complex cross-border route that demands precise engineering, strict regulatory compliance, and continuous coordination between logistics teams, escort services, and authorities. The convoy is built around a multi-axle modular trailer system, configured to distribute extreme axle loads while maintaining structural stability over long distances. A high-power tractor unit provides the primary tractive effort, supported by auxiliary pusher and puller vehicles where gradients, tight curves, or urban restrictions require additional torque and braking control. Hydraulic suspension allows real-time adjustment of deck height and load leveling, ensuring consistent ground clearance and minimizing stress on both the cargo and the road infrastructure. Route planning is a critical phase of this project. Detailed surveys are conducted to evaluate bridge capacities, pavement strength, turning radii, overhead clearances, and traffic constraints. Temporary traffic management plans, including lane closures, rolling roadblocks, and nighttime movements, are implemented to reduce public disruption and to enhance operational safety. In certain sections, roadside furniture and temporary obstacles must be removed or repositioned to create a passable corridor for the load. Cross-border transport introduces additional complexity. Permits, police escorts, and timing windows are synchronized between Czech and Slovak authorities to ensure uninterrupted movement across national boundaries. Communication protocols between convoy leaders, escort vehicles, and control centers are maintained continuously, allowing immediate response to changes in traffic conditions, weather, or technical issues. During transit, speed is strictly limited, and braking distances are significantly increased due to the combined mass of the vehicle combination. Steering inputs are carefully managed to control trailer articulation and prevent excessive lateral forces. The modular trailer's self-steering axles assist in tracking through tight curves, reducing tire scrub, and improving maneuverability in constrained urban environments. The successful delivery of this abnormal load to Bratislava demonstrates the integration of mechanical capability, logistical planning, and regulatory coordination. Such projects highlight the essential role of heavy-haul transport in supporting large-scale industrial development, where components of exceptional size and weight must be moved safely, efficiently, and with minimal impact on public infrastructure and traffic networks. Superpesa Exusiminus O2 documents one of the most demanding heavy transport operations executed in Brazil, involving the relocation of atmospheric oil separation towers manufactured by Usiminas Mecanica in Ipatinga, Minas Gerais. These industrial columns, each with an average weight of approximately 200 tons and extreme dimensional characteristics, were critical process units for a Petrobras refinery expansion project. In total, 8 towers were scheduled for transport, placing extraordinary requirements on route engineering, equipment selection, and operational coordination. The logistics chain began at the fabrication yard in Ipatinga, where the towers were prepared for overland movement. Specialized lifting systems and self-propelled modular transporters were used to position the units onto multi-line hydraulic modular trailers configured for high payload distribution and low deck height. Due to the length and slender geometry of the columns, load stability and center of gravity control were key engineering considerations during both lifting and securing operations. The road journey from Ipatinga to Vitoria in the state of Espírito Santo represented the most complex segment of the transport. This corridor includes mountainous terrain, restricted urban passages, bridge load limitations, and tight horizontal and vertical clearances. Prior to execution, Superpesa conducted extensive route surveys, structural assessments, and feasibility studies. Temporary civil works, including pavement reinforcement, removal of roadside obstacles, and local infrastructure adaptations, were required to ensure safe passage of the convoys. Each movement was executed under controlled speed and convoy conditions, supported by escort vehicles, traffic management teams, and continuous communication between drivers, engineers, and logistics coordinators. The modular trailer configurations, combined with hydraulic steering and suspension systems, allowed precise maneuvering through curves and grade changes while maintaining acceptable axle loads and structural stability. The operation highlights Superpesa's capability to manage large-scale, high-risk industrial logistics, from factory gate to refinery site. Through advanced engineering, disciplined execution, and coordinated stakeholder involvement, the transport of these atmospheric separation towers demonstrates the level of planning and technical control required for modern heavy-haul projects supporting Brazil's energy infrastructure development. The Panther Series 2 low loaders, rated from 80 to 130 tons, are engineered for safe and efficient transport of heavy machinery across demanding site conditions. Designed and manufactured using OEM-grade components in a state-of-the-art Bunbury facility, these trailers deliver exceptional durability and performance. A seamless transition from ramp to deck creates a shallow approach angle, allowing easy, unassisted loading and unloading for operators. The rear axle rotational system enhances stability, optimizes overall trailer length, and provides high ground clearance for superior mobility in mining and industrial environments. Safety is reinforced through wet disc brakes combined with an electronic proportional braking system. With full deck ground contact during loading, stability is maximized. Integrated control systems with touchscreen monitoring, data logging, and remote operation make the Panther Series 2 a truly intelligent low-loader solution, ready for modern and future mining operations. A Tesmec 140-ton trencher is being transported using a Goldhofer THP SL modular trailer system. coupled with a powerful man TGX 680 WSK prime mover, forming a highly specialized heavy-haul convoy. This configuration is engineered for the movement of The Goldhofer THP-SL platform provides modular axle combinations, hydraulic suspension, and electronic steering control, allowing the load to be evenly distributed and maintaining stability over uneven road surfaces. The trencher, a high-production machine designed for large-diameter trenching and continuous excavation, is carefully secured to the trailer to prevent dynamic load shifts during transport. The MAN TGX 680 WSK delivers exceptional tractive effort and torque, enabling controlled acceleration, reliable braking, and precise maneuvering, even on gradients and tight curves. Escort vehicles and route planning are essential to ensure compliance with road regulations and to manage clearances along the transport corridor. This operation highlights the complexity of heavy machinery logistics, where engineering expertise, advanced transport equipment, and disciplined coordination combine to move critical infrastructure assets safely and efficiently to the job site. This heavy, oversized convoy features two Caterpillar 793F mining dump trucks, both transported on tri-drive heavy haulage combinations while ascending Bindoon Hill. The steep gradient and limited roadway width demand high tractive effort, synchronized throttle control, and precise braking management. Escort vehicles manage traffic and clearances while the prime movers maintain stable speed to prevent load shift. The operation demonstrates disciplined convoy coordination under demanding gradient and mass conditions. Triton Transport Services undertakes the relocation of a Litorno L2350 from Perth, handling one of the most powerful wheel loaders ever engineered. The movement of this ultra-class machine requires specialized heavy-haul trailers, high-capacity prime movers, and meticulously planned logistics to accommodate its exceptional operating weight and dimensions. The L2350 is fitted with the world's largest production wheel loader bucket, offering a maximum capacity of 40.5 cubic meters. It delivers a rated lift capability of 574 kilograms, enabling the loader to fully charge an ultra-class Terex MT6300 haul truck, rated at 363 metric tons, in only 5 loading passes and in just over 3 minutes. This unmatched loading performance significantly improves mine cycle efficiency and reduces truck queuing time. The L2350 remains the only wheeled loader globally designed specifically to service the larger Terex MT6300 class haul trucks, establishing a benchmark for high-output surface mining operations. This tri-drive Mack Titan is engaged in the transport of a Caterpillar 785C rigid mining dump truck, a machine with an operating weight of approximately 710 kilograms. The Titan's multi-axle drivetrain provides the high tractive force and load distribution required for extreme heavy-haul applications, while maintaining road stability under concentrated axle loads. The low loader configuration supports the massive chassis and wheelbase of the 785C, securing the load's center of gravity and controlling dynamic stresses during acceleration, braking, and cornering. The Caterpillar 785C is widely used in large-scale surface mining operations, valued for its high payload capacity, structural durability, and reliable powertrain performance. Transporting equipment of this size demands precise route planning, reinforced trailer systems, and coordinated braking management, all of which are demonstrated in this heavy-duty haul. A rig move refers to the complete process of dismantling, transporting, and reassembling a drilling rig from one location to another, a critical operation in upstream oil and gas logistics that demands precision engineering and synchronized execution. In the case of a rig move in a day, this complex procedure is compressed into a single operational window, requiring meticulous planning, specialized equipment, and real-time coordination across multiple teams. Before sunrise, rig move preparation begins with route surveys and safety briefings. Detailed assessments of road conditions, overhead clearances, weight restrictions, and permit requirements are completed in advance to avoid delays. Transport routes are selected to minimize disruptions, and traffic control plans are coordinated with local authorities. Rigging crews secure all rig components according to certified lifting and load restraint standards. The rig itself is first rigged down. Major assemblies such as the mast, substructure, drilling floor, drawworks, power packs, mud pumps, and auxiliary systems are systematically disconnected. Each component is tagged, balanced, and prepared for transport by heavy haul trailers and modular transporters. Because a drilling rig consists of tall, wide, and heavy structures, specialized trailers with multi-axle configurations and hydraulic suspensions are used to distribute loads evenly and comply with highway safety regulations. Once the rig-down sequence is complete, the convoy assembles. The transport team employs a combination of lowboy trailers, hydraulic modular units, and heavy prime movers. Escort vehicles and lead pilot cars maintain communication with the convoy, monitoring speed, steering adjustments, and lateral clearances. On public roads, movement is restricted to daylight hours, and speeds are limited to maintain control and visibility. While transport is underway, a parallel crew prepares the new well site. Foundations are leveled, utilities are positioned, and crane pads are set. Precision is essential, as cranes with specific lifting capacities must be staged and aligned to receive rig modules immediately upon arrival. This overlap of transport and site readiness is what makes a same-day rig move possible. Upon arrival, the unloading and reassembly sequence begins. Cranes lift major components directly from the transport trailers into place. The mast is erected first, followed by the substructure and critical drilling systems. Mechanical alignment, structural bolting, and hydraulic and electrical reconnections occur systematically under the supervision of rig supervisors and engineers. Safety protocols dictate strict exclusion zones, continuous radio communication, and redundancy checks at each step. The final phase is the rig-up and pre-operational inspection. All systems, mechanical, electrical, and hydraulic, are inspected, tested, and certified before the rig becomes operational. Achieving a rig move within 24 hours not only minimizes downtime, but also enhances project economics and schedule reliability. Successful same-day rig moves reflect the seamless integration of advanced transport solutions, experienced rigging crews, and disciplined operational control, enabling drilling operations to transition quickly and safely between well locations. This scene captures a coordinated heavy haul operation in which two powerful trucking rigs work together to relocate an oversized industrial load. One prime mover provides the primary pulling force, while the second unit functions as a pusher, supporting traction and braking control on gradients and during low-speed maneuvers. The load is mounted on a multi-axle low-bed trailer, ensuring proper weight distribution and structural stability. Continuous communication between both drivers is essential to synchronize acceleration, steering, and braking. This dual-tractor configuration significantly improves safety, mobility, and control when transporting exceptionally heavy or dimensionally critical equipment. Oversized equipment transport is a highly specialized logistics operation where distance is long, road geometry is restricted, and working conditions are severe. Every move requires route surveys, structural checks, escort coordination, and precise load distribution. Multi-axle trailers, hydraulic suspension systems, and high-power prime movers ensure stability and traction on steep grades and tight curves. Continuous monitoring of axle loads and vehicle dynamics is essential to protect infrastructure, maintain safety, and deliver heavy industrial components reliably under extreme transport conditions. The operation shows a large coil tubing unit weighing approximately 250,000 pounds, being recovered from a difficult work site using two heavy-duty scrapers operating in parallel. Due to its high center of gravity and concentrated mass, this type of oil-field equipment requires extremely controlled handling during any relocation or recovery process. The two scrapers are positioned to deliver balanced and synchronized pulling force, keeping the load aligned and preventing lateral drift or structural twisting. High-capacity tow bars and reinforced connection points are used to safely transmit the drawbar load. Ground conditions are inspected in advance, and traction pads are prepared to reduce resistance and avoid excessive sinkage during movement. Throughout the maneuver, operators maintain constant radio communication, coordinating throttle input, speed, and steering corrections. The unit is moved at a low, steady pace to protect the chassis, reel assembly, and hydraulic systems from dynamic shock loads. This recovery method demonstrates an effective solution for relocating oversized coil tubing equipment in remote oilfield environments, minimizing mechanical risk, reducing downtime, and ensuring a high level of operational safety. The Zetterberg ZD4 cassette, specifically the ZD4K automatic cassette, is a chain-driven construction cassette system designed to streamline heavy-duty work vehicle operations in infrastructure and construction applications. It features a dual-speed hydraulic chain drive with automatic electrical and brake coupling disconnection, enhancing load handling and maneuverability in confined work zones. The unit includes secure double locking, mechanical and pneumatic, and a parking position with damping elements for even weight distribution and reduced noise, improving efficiency and operator control on-site. Here at Longbridge Gully, on the Great Northern Highway, north of Bindoon in Western Australia, a highly coordinated heavy transport operation is underway, combining hazardous materials logistics with extreme oversized haulage. Leading the movement are 3 green toll mining services trucks, transporting ammonium nitrate for blasting operations at regional mine sites. The Kenworth T909 operates bulk loading tipper trailers, while 2 Kenworth K200 prime movers carry bulk bags on flat-top trailers. These vehicles maintain strict spacing and regulatory compliance due to the sensitive nature of the cargo. Following closely is an 8.5-meter-wide heavy oversize 2-truck convoy transporting Komatsu mining dump trucks. The first unit is hauled by a Centurion Transport Kenworth C508, assisted by a Kenworth K200 pusher truck to manage grades and braking forces. The second load is handled by a Kenworth K200 prime mover, supported by a Mammoet Australia Western Star block truck acting as the pusher. This configuration provides the tractive effort and control required for extremely heavy rolling resistance and wide load stability. This operation demonstrates the integration of hazardous goods transport, heavy haul engineering, and convoy management, ensuring that critical mining equipment and materials are delivered safely, efficiently, and in full compliance with Western Australian heavy transport regulations. A Caterpillar D8R crawler dozer powers through soft sand dunes, pulling heavy equipment across unstable terrain. Its wide tracks, high drawbar pull, and robust undercarriage deliver exceptional traction and stability, proving the D8R's capability in extreme off-road hauling and demanding earth-moving conditions. In this operation, Felbermayr relocates the base unit of its Liebherr LR 11,000 crawler crane within a wind farm in Lower Austria, using a 12-axle self-propelled modular transporter, SPMT. The move takes place between 2 wind turbine installation positions, where terrain access is limited and conventional heavy-haul tractors cannot be used efficiently. The LR 11,000 is one of the world's largest crawler cranes, and even in stripped configuration, the basic machine represents an extremely high concentrated load. The SPMT provides the necessary maneuverability, precise steering control, and axle load distribution required to travel safely over prepared turbine service roads and compacted ground surfaces. Hydraulic suspension ensures constant load leveling, while electronic steering allows crab, carousel, and diagonal movements, enabling the transport unit to negotiate tight curves and restricted clearances between turbine foundations. The modular configuration also permits rapid adaptation of axle numbers to match ground-bearing capacity and machine weight. This internal relocation method significantly reduces dismantling and reassembly time compared with traditional crane walking procedures. As a result, overall erection cycles are shortened, site congestion is minimized, and lifting operations can resume more quickly, improving productivity and safety across the entire wind farm project. The Hwasun Wind Power Plant project documents the complex process of transporting and installing large-scale wind turbines across challenging mountainous terrain. From the outset, the operation required strict route planning and the use of purpose-built heavy transport equipment, as the access roads were narrow, steep, and engineered specifically to meet wind turbine logistics requirements. A key element of this project was the application of the KTB-1000 blade transport system, a patented solution developed in Korea for the safe handling of long and highly flexible turbine blades. This specialized carrier enables controlled articulation, precise steering, and optimized load distribution, allowing oversized blades to be maneuvered through tight curves and variable gradients with a high degree of stability. Dedicated prime movers, combined with cranes configured for cold and snowy conditions, ensured reliable performance throughout the installation phase. Lifting operations were carefully synchronized to account for wind speed, temperature, and ground-bearing capacity, minimizing risk and maximizing productivity. Through the integration of specialized transport technology, experienced operators, and detailed engineering preparation, the Hwasun project achieved rapid, safe, and efficient turbine erection, demonstrating best practices for wind farm development in complex topographical environments. The Koreadel's KTB-1000 blade transport system is a purpose-built solution for the safe and efficient movement of wind turbine blades across challenging terrain. Designed specifically for oversized composite structures, the KTB-1000 supports controlled lifting, rotation, and steering of long blades, allowing transport through narrow mountain roads, tight curves, and steep gradients that are impossible for conventional trailers. The hydraulic cradle securely grips the blade root, while the rear dolly and steering system maintain precise alignment and load stability throughout the route. During operation, the blade can be elevated, tilted, and rotated in real time, enabling obstacle clearance over road infrastructure and surrounding terrain. This significantly reduces route modification requirements and minimizes environmental impact. With its patented Korean engineering, the KTB-1000 improves transport safety, shortens installation schedules, and plays a critical role in modern wind farm construction logistics. A huge abnormal load is carefully transported through the streets of Trichard, demonstrating the complexity of modern heavy logistics operations. The cargo is carried by a powerful red heavy-duty tractor, coupled with a specialized low-bed trailer designed for oversized industrial components. The massive structure, partially covered for protection, occupies almost the full width of the roadway, leaving minimal clearance on both sides. Such abnormal transport requires detailed route surveys, traffic management planning, escort vehicles, and strict compliance with safety regulations. Every movement is precisely coordinated to ensure stability, public safety, and the protection of surrounding infrastructure, highlighting the engineering and logistical expertise behind heavy haulage operations. A heavy timber truck becomes immobilized on a muddy mountain road, where saturated soil and loose aggregate have drastically reduced traction. Prolonged rainfall and localized slope instability have turned the unpaved surface into a deep, rutted section, causing the vehicle to lose momentum and sink into the soft ground, blocking traffic along this narrow route. To resolve the situation, a Manitou TLB 844SX4 loader backhoe is deployed to assist in the recovery. Using controlled pushing force and precise bucket positioning, the operator stabilizes the truck while the driver carefully modulates throttle and steering input. This coordinated effort between machine operator and truck driver is essential to prevent further slippage and potential rollover. Such incidents are common in hilly and remote areas during the rainy season, where drainage is limited and road structures are vulnerable to erosion. Beyond disrupting local transportation, these events directly affect timber supply chains, rural mobility, and daily economic activities, highlighting the critical importance of proper road maintenance and rapid response support equipment. The excavator demonstrates a controlled self-loading procedure using only its hydraulic working equipment with no access ramp available. This method is commonly applied in confined or remote job sites where auxiliary loading infrastructure is not practical. The sequence begins by positioning the machine squarely in line with the truck. The bucket is carefully placed onto the truck bed, allowing the front structure of the excavator to make stable contact with the platform. The operator then curls the bucket rearward using the hydraulic force of the linkage to lift the front of the machine off the ground. Simultaneously, the travel motors are engaged, driving the undercarriage forward while the bucket continues to support and elevate the upper structure. This synchronized motion gradually transfers the machine's weight from the ground to the truck, enabling the tracks to climb smoothly onto the deck. Throughout the maneuver, precise coordination between the boom, arm, bucket, and travel functions is essential to maintain stability and to control the center of gravity. Smooth, progressive movements minimize dynamic loads and prevent sudden shifts. This technique highlights both the versatility of hydraulic excavators and the importance of operator skill when handling heavy equipment without external loading aids. A Terex mini excavator is unloaded from a transport truck using a controlled self-unloading technique, without ramps and without auxiliary lifting equipment. The operator uses the boom, stick, and bucket as a stabilizing support to gradually transfer the machine from the truck bed to the ground. With the engine running at low, steady RPM, the bucket is placed firmly on the ground behind the truck. The boom is then extended while the undercarriage is slowly driven backward, allowing the bucket to carry part of the machine weight. This creates a three-point contact system between the tracks and the bucket, maintaining stability throughout the descent. By carefully modulating hydraulic pressure, the operator lowers the center of gravity and prevents sudden load transfer. The tracks remain aligned with the truck deck to avoid lateral slip, while the bucket angle is continuously adjusted to control the descent speed. Once the rear of the tracks reaches ground level, the boom is retracted and the front of the undercarriage is eased down in a controlled motion. Final positioning is completed after full ground contact is achieved. This method requires high operator skill and precise hydraulic control, ensuring safe unloading in confined or uneven site conditions. The Kraz 255B, a heavy-duty 6x6 military truck, is shown transporting and unloading a BMKT tugboat during the amphibious vehicle meeting in Putnitz in 2012. This operation demonstrates the versatility of the vehicle and its suitability for demanding off-road and amphibious support tasks. At the waterside of the Sullerboden, the Kraz carefully positions itself to provide a stable platform for the unloading process. Using controlled vehicle movements and the integrated handling equipment, the Bugsier boot is gradually released from the transport frame and guided into the water. The robust chassis, high ground clearance, and powerful drivetrain of the Kraz 255B allow it to operate reliably on soft ground and uneven terrain, which is essential for shoreline deployment. The BMKT tugboat is designed to support amphibious operations by assisting with maneuvering and positioning of other watercraft. This coordinated procedure highlights the practical combination of military transport engineering and marine support capability, ensuring safe and efficient launch operations in challenging environmental conditions.